Hi all, welcome to the video. In this video, we'll talk about what is hyperparameter tuning, and I will try to keep it very simple and so that each and everyone, even for someone who is just starting out in ML and R, can basically understand that. So if I will try to give you a background about decision tree, okay, and since we are talking about hyperparameter tuning, I'm taking random forest as an example, as a context. So everybody knows that this is a decision tree. Now, in order to overcome the shortcomings of a decision tree, what we do, we actually club a couple of decision tree together and then basically collate their output so that we get a improved learner in comparison to a single decision tree. Okay, but this creates a problem because we have to combine a certain number of decision tree, and then for each decision tree there are certain number of parameters like what is the height to which we want to grow the decision tree, how many features will be used, what is the total number of leaf nodes or terminal nodes. So all these things have to be kept in mind, and just to summarize everything, we have to decide the total number of decision tree. You have to also decide for each decision tree what will be the terminal number of nodes, what will be the total features used in each tree while we train the model, and then what will be the maximum depth. Now, uh, this information can be overwhelming because we don't know for sure what will be the optimal set of these values that will give us the correct result, or which will basically serve our purpose. Let's say if we are trying to create a default model and our goal is to basically improve the accuracy, then if deploying random forest model will certainly involve identifying these parameters, and they we cannot just simply assign random values to these parameters. There has to be a certain way, and that particular method is known as hyperparameter tuning. We'll just look into the other slide. So how do we actually identify those optimal values? We basically, let's say to start with, we create a learner. Uh, just just to give you an example, let's say if we are in a classification problem, we will create a classification learner. And if we are into a regression problem, we will create a regression learner. Once we set up that learner, we will then identify the variables that we want to identify, or we will identify the variables for whom we are trying to identify optimal values. And we will assign certain range for each value. Like, let's say if we are trying to identify the optimal number of trees in a random forest, so we'll say, okay, identify optimal number of trees between range 10 to 20 or 10 to 50. Similarly, if we are trying to identify terminal number of nodes, so we'll say identify optimal number of terminal nodes or terminal leaves within these nodes in the range of 5 to 15 and so on. So that we will basically set up that grid. Once that grid is set up, we will also indicate how many times do we want to identify or basically run the entire process. Normally if we run it for few number of iteration, the process will end pretty quickly. However, if we run it for large number of iteration, it will run for a long time. One more thing that we need to consider here is the use of n-fold cross validation. I will create a separate video just to give so that we understand it in more detail, but just to give you some background. So let's say we have a very biased sample, and if we just create a train and test data set, there are high chances that the bias might still be there in those individual data sets. So therefore, for now, just think of it as something that removes that bias, which is n-fold cross validation. Popular n-fold cross validation techniques include three-fold cross validation, five-fold cross validation. Once that is done, we combine everything and then we create a task, because ultimately it has to be set up as a task so that we can run that task and identify optimal values of those parameters. And once the entire setup is done, we tune parameters and we identify optimal values. uh, I will try to basically give you, I will try to take a problem. Let's say let's take a default classification problem, and we'll try to go through these steps and identify how we can identify optimal set of parameters and improve accuracy. uh, Before ending this video, I would just like to show you something. All the people that are spending more time on my channel are not subscribers. They have not subscribed to my channel. So I would just request everyone to basically subscribe to my channel if you really like the content. And I hope this video was useful. Do give it a thumbs up.